Good morning to all. I am Niveta. Now we are going to see architecture of 8051. 8051 is a microcontroller. The word microprocessor means CPU only. The function blocks memory and other peripherals are to be connected externally to the microprocessor chip to make a complete microcomputer. But the microcontrollers are having all these facilities in a single chip. The microcontrollers are used for general purpose applications in the sense that they are user programmable and have functional blocks suitable to meet more general design requirements. The main features of microcontrollers are high integration of functionality and the field programmability, flexibility, and microcontroller is very easy to use. In this architecture, the Intel 8051 contains two separate buses for both the programs and data. So there are two distinctive memory spaces, 64K into 8 size both programs and data. That means that RAM have a 128 bytes of memory. It's based on the 8-bit central processing unit within an 8-bit accumulator and another 8-bit B register as a main processing blocks. Other portions of the architecture includes few 8-bit and 16-bit registers and 8-bit memory locations. It has some amount of data RAM built in the device for internal processing. This area is used for stack operations and some temporary storage of data. This 8051 microcontroller is supported with on-chip peripheral functions like I/O ports, timers or counters, serial communication port, etc. In this block diagram, 8-bit CPU with registers A means that accumulator and B register, and 16-bit program counter and data pointer. Data pointer means here we are mentioned a DPTR, and 8-bit program status word that is mentioned in a PSW. 64K program memory address space. The 64K data memory address space 128 bytes of memory and chip data memory. The external and 3 internal interrupt sources are used. On chip clock oscillator is used. In this here ALU it's working as a CPU. The CPU is the brain of the microcontroller, reading users programs and executing the expected task as per instructions stored on the end. It's a primary in this microcontroller. The primary elements is an accumulator, B register, stack pointer, program counter, PSW and DPTR, and some few more 8-bit registers. First we see accumulator. The accumulator performs arithmetic and logical functions on 8-bit input variables. Arithmetic operations includes addition, subtraction, multiplication, division, etc. Some logical operations are AND, OR, XOR, as well as rotate, clear, complement, etc. Apart from the entire above, accumulator is responsible for conditional branching, decision making, and provides a temporary place in a data transfer operations within the device. And the next is B register, which is used to multiply and divide operations. But in the microprocessor, the successive addition and successive subtraction is there. But in with the use of B register, we can use multiply and divide operation directly. During execution of this B register, either keeps one of the two inputs and retains a portion of the result. For the other instruction is used to as a general purpose register. Next we are moved to stack pointer. In the stack pointer, it's one of the 8-bit register. This pointer keeps track of memory space where the important register information are stored when the program flow gets into executing a subroutine. Program counter. Next program counter is the 16-bit register giving address of next instruction to be executed during program execution, and it always points to a program memory space. And the DPTR also called as a data pointer, is the 16-bit addressing register that can be used to fetch an 8-bit data from the data memory space. When it is not being used in this purpose, it can be used as a 2 8-bit register. That means a data pointer high and the data pointer low. Next, program status for it's the outcome of ALU, that means arithmetic and logic unit, which keeps the current status of arithmetic and logical operation in different bits. The 8051 has a 4 math flags that respond automatically to the outcomes of arithmetic and logical operation, and we are using a 3 general purpose user flags that can be set 1 or clear to 0 by the programmer as desired. The math flags are carry, auxiliary carry, overflow, and the parity. Next, input and output ports. 8051, this microcontroller has 32 IO pins configured as a 4 8-bit parallel ports, that is considered P0, P1, P2 and P3. Each pin can be used as an input or as an output under the software control. These IO pins can be accessed directly by the memory instruction during program execution to get required flexibility. At the beginning of an external memory cycle, lower order 8 bits of the address or address bus are output on P0, that means port 0. The same pins transfer data byte at the later stage of the instruction execution. These port lines can be operated in different modes, and all the pins can be made to do many different tasks apart from the regular IO pins executions. Port 0 is used as a multiplexed address and data bus. With the use of arithmetic and logic unit, we can demultiplex the address and data buses. Any instruction that acts as external program memory will output the higher order byte, that means A8 to A15, and port 2 on during read cycle. Next, port 1 and port 3 are available for standard IO functions. Port 3 pin has additional functions: 2 external interrupt lines, 2 counter inputs, and 2 serial port data lines, and 2 timing control strobe lines. Next, on timing and counter, 8051 has 2 16-bit timers and counters, T0 and T1, capable of working in different modes. Each consists of a high byte and then low byte, which can access under software. In this timer and control, we can set T mode and T-con. T mode means a timer mode control register, and then T-con is a control register to configure these timers and counters in a number of ways. Next, serial port. In the serial port, 8051 has a speed of full duplex serial port, which is software configurable in 4 basic modes: shift register mode, standard UART mode, multiprocessor mode, 9-bit UART mode. And then finally, oscillator. The 8051 generates the clock pulses by which all internal operations are synchronized. Pins XTAL1 and XTAL2 are provided to connecting a resonant network to form an oscillator. To form this crystal clock frequency, a quartz crystal is used for oscillator. The crystal frequency is the basic internal clock frequency of the microcontroller. I think next, timing and control. Timing and control have 4 pins: P sign, ALE, A bar, and RST. RST is a reset pin. If you want to reset the total power on rest, that means when activating a high pulse, it's a pin microcontroller will reset and all values in the register should be lost. The reset values of some registers is depending upon the program counter, accumulator, and B register, DPTR, etc. Next, external access. This input pin is connected to either VCC or ground. The microcontroller family members, it's on chip ROM, some stored programs, EA pins. That pin number is 31, which is connected to the VCC in the microcontroller. For example, 8031 family members, there is a no on-chip ROM code stored on external ROM and fetched by the 8031. Here, the EA bar pin is connected to the ground to indicate that code is stored externally. And then PSEN, that means a program store enable. This is an output pin and the pin number is 29. In this microcontroller based system in which an external ROM holds a program code, this pin is connected to the OE pin or a ROM. Next, as a address latch enable, this is an output pin and it's an active high signal. When I connected to a 8051 microcontroller to the external memory, port 0 provides both address and data. In other words, the 8051 multiplexes address and data through port 0 to save pins. If ALE signal is 0, port 0 provides a data lines, that means a D0 to D7. If ALE having a high signal is equal to 1, it has the A0 to A7. And that's all about the 8051 architecture. The total program is connected to total architecture is connected to VCC and the lowest signal is a ground. It has a 40 pin DIP. It's a dual inline package.